Right, in this video, I'm going to show you how I brute force the main login page of DVWA, which ends its path with login.php, which isn't even an actual task. I'll show you a quick glimpse of Hydra, which is the tool that I'll use, and show you under the hood how it cycles through the credentials. So let me quickly throw up the command and get that to execute. And now you can see Hydra in action, iterating through the list of passwords, in this case, that I've instructed it to use. Now I'm going to cancel that command now and amend it so it will brute force the main login page, which is primarily why you're here. And here we are. The main login page has now been successfully brute forced. If you want to find out how I did this and do a deep dive into this unofficial task, then this video is for you. Hello and welcome to another video from TechBeats. Today we're going to brute force the main login page of DVWA. To clarify, I'm brute forcing the main initial login page, which is DVWALogin.php, which I'm just showing you. And that's not to be confused with the brute force task, which I'll show you now. And that has the path of DVWA vulnerabilities brute. The login.php path is not actually a task, but in the spirit of brute forcing, why not? Because we're brute forcing the main login page, the level is actually set to impossible, which you might have just seen when I was logged in. And that's the default level before you go in and actually change it yourself. There are very few resources on this, so I wanted to make a detailed guide and just go through in a bit more detail because I know it can be a bit challenging. Now, this video is a little bit longer than I was aiming for, but it's to try and explain as much as I possibly can. So if you need to, feel free to skip over wherever needed. If you're after the actual official brute force task, which points to the page that we were just on, that's DVWA/vulnerability/brute. And don't worry, I made a separate video on that task as well. If you want to take a look, I'll leave a link in the description below. The key points to have in mind is that we'll be brute forcing using HTTP post method with CSRF tokens. That's user tokens as it's seen in the code. To make sure you don't waste your time, I'll also highlight the key areas in my command so you can establish whether this is the right tutorial for you. Now, looking at the Hydra command, you can see that I've got the correct path in here, which is login.php. It's the right credential pair, we know from the task, admin and password. It's only giving us one credential pair, not 16 or any false positives for that matter. And it's locally hosted, which is on the address. So you can see localhost there. And this also confirms that it doesn't matter if you host a DVWA server to localhost or another machine on the network, which may then have an IP address beginning 192.168.something.something. And lastly, notice how there's no additional switches, don't need to configure the timing or even wait times. So if you've made it this far, then this video is probably for you. I'll leave the content headings in the description below as well. So if you need to skip over or refer to any section again, that should hopefully make it easier for you. All right, date is set so we can get cracking. So the objective, that's the goal of the task. I'm going to begin by clarifying the objective. I'll be brute forcing the main login page, which we're on right now. This is the first page you see when you load up the DVWA, i.e. path, you can see DVWA/login.php. Not to be confused with the actual brute force task, which relates to the path DVWA/vulnerabilities/brute task URL, so that's confirming the target. As you can see, my URL path is correct in the terms of the login page that we need. Now you can put in, instead of localhost, you can put the IP address. So you could put 127.0.0.1, and this has no effect on Hydra's command or brute forcing, as the operating system will just interpret localhost as the IP address anyway. Moving on to tools. Right, the tools. Tools required to formulate and execute the brute force task. So I'm going to be using Hydra, and this is the GitHub repo for Hydra itself. Now it's, as they refer to it, a parallelized login guesser, which essentially means it's a tool for guessing valid login password pairs very quickly, as you saw earlier in the video. You can also use Potato, although the syntax is slightly different, and also Burp Suite as well, which also then replaces the need for web developer tools, which I'll be using. You obviously need the DVWA server. I'm using a Kali-based server running from VirtualBox VM. You need a web browser in my case. That's optional, as I'll show you throughout the video. There's another version, which is the CLI version we can embed. But where I use a web browser, I'm using Firefox. And within that, I'm using the web browser developer tools, and that's built into most common browsers. There's curl as well, so that's a CLI-based browser option. We need to essentially view source code. And also, I initially needed to automate the token creation, but this was not needed, which is explained towards the end of the video. We also, and lastly, need word lists. There are inbuilt word lists within Kali Linux, or you can download from a repo like seclists, for example. I'll leave a link to that. Moving on to the infrastructure. So to set up the infrastructure, we are basically preparing our environment. So start your DVWA web server. So I'm going to do sudo service mysql start. And in a few of my commands, you'll see I put a dot in first and then remove it after. That's basically to remove the auto typing so it doesn't kind of throw up or confuse anyone with any similar commands. Input your password for the VM. That's now started. And we'll just do the same with the web server, which is Apache in my case. Now, Hydra should come pre-installed in Kali Linux, but if you need to install it, then the command is sudo apt-get install Hydra or Hydra-gtk. I'll leave a note in the description. There was a reported bug in version 9.1, so update it to the latest stable repo. To check your version type, you can just do this. So Hydra -- version, and then you can see my version is 9.3. Next, what we'll do is update the repo. Let that run. And there's not too many things because I update it fairly regularly, so that's all done there. Now we can launch the server from a web browser now. So we can do that straight from here if you want. Firefox, localhost, DVWA-login.php. In my setup, I will clear the cookies from the web browser, Firefox, to remove any saved data from interfering with results or the command. And that's done. All right, so the information required for Hydra. So high level, we'll just go back to the command that was executed earlier, and I'll just break it down what we have here pieced together. So that line was my command, just highlighted there. And what that includes and instructs Hydra with the necessary information is the hostname or IP. This is effectively the DVWA web server folder name. So if you've changed it, then you need to amend it accordingly. In mine, you can see it's in small cases because I did change it to make testing a bit easier. URL service, method or scheme, however you want to refer to it, that's the protocol to access the resource, i.e. whether it is a HTTPS or HTTP service or protocol, and form type. So that's a GET or POST request. Next is the parameters of the request. That's within the double quotes that you can see. Path, the relative path to the target location. We then need the iteration field. So we need to instruct Hydra where to iterate the actual fields and with what data. Then got a flag. So that establishes the difference in response between success flag to look for and a failure flag. So what that's not to look for. So it's similar to the concept of a firewall. Session cookies. So whether session cookies are required to be set or maintained. Any lockout features that may be present, the features and thresholds that apply to them on the form. Word lists, so to allow the iteration of respective fields, username and or password fields. Easier testing purposes, I've input the username, but I'm just going to iterate the password fields, and that just makes it easier if you're trying to debug things. Port number, that should only really be used in certain use cases. In our case, it should be automatically established by Hydra when the method or scheme section is defined. A port number should only be used if using a different port to the officially known port numbers, or in some cases there's an error perhaps. So we won't be defining a port number, as it will be port 80 by default, and that'll be visible when Hydra executes. You can see in the command output that it's given us. This would change to port 443 had we installed an SSL certificate on the web server, but we haven't done that in our case. So that's the outline of the command itself. We're going to now move on to information gathering, which is referred to as reconnaissance, and this is quite a large section of the video. So let's head back over to Firefox and go to the main login page. I'm just going to refresh the page, and then what we'll do is submit an arbitrary login pair just to observe the traffic inside the web developer tools. The shortcut to that is Control-Shift and I. That might be different on a different web browser. So Control-Shift-I, just reload that page, and then we'll put an arbitrary login pair, as I said. So anything and anything. Press enter, and we see what comes up there. So let me just rewind a little second, and we'll just refresh the page. And here you see that there are 3 methods, and these are all GET requests. So you can see the methods down here. Now, if we submit that arbitrary login pair again, so anything, anything, press enter. Now we notice a change. So if we inspect this data a little bit closer, we notice a post request in the second field. So let's just get the order of this right. There's our post request. Now this implies to me that we may be dealing with a redirection from the Apache web server. So let's click that. After inspecting each method, or have a chance to have a look at it yourself, there is a good indicator that we should pay attention to the post request. Within the request tab of this data, we can see the credentials we input. Note the other 2 fields do not contain these credentials. The data is telling us that upon submitting credentials, that's anything that we input, the server responds with a 200 OK message. So we'll just go through this in order. This is a success status response code indicating the request succeeded. So this is server statuses, okay? The additional information telling us it's a GET method means the resource has been fetched and is transmitted in the message body. So here's the response. So going to the post method, submits our details as this is a login form, and hence why the credentials are in the field, as we saw in request details. The server response code here is 302. That's the HTTP 302. It's a found redirect status response code. And that again indicates that the resource requested has been temporarily moved to the URL given by the location header, which we see here. A browser redirects to then the page that it's given. This is another indicator that there is a redirect being performed by the web server. Go on to the third and final. So the server then uses the information submitted to do something. Whilst we assume it will try to authenticate the login credentials as a valid or invalid user, this hasn't yet been confirmed, albeit this should be the purpose of the server to client communication. To support our current theory, we now have data in the response tab which states that the requested URL was not found on this server. So that's going to this response here, and we can make it raw to condense it a bit, and it will tell us the same thing in the HTML format. So that completes the round trip communication that occurs upon submitting a set of arbitrary or incorrect credentials, as we saw. We may then need to refer back to this data to help create a failure flag or for Hydra if appropriate, seeing as we have some idea or information on what the output of an incorrect login pair now looks like. So this explains why we will use the post form method. So that's http-form-post, as we saw in the command execution. We can see that the flow or sequence upon submitting a login credential are the following in order then. So as the status code, method, and file. As I mentioned, we request the website page for the URL, which is shown above. We then get the 200 get login.php. That's just following this information here. And that's the server providing the page which rendered the main login page. The next one is the 302 post login.php. This means that we post our credentials in the form and submit it to the server. The 404 get favicon.ico, that's the server responding, stating login failed, and the HTML response states that the URL was not found on this server, implying a redirection rule may be present. To add some further information on the status codes, 200, as I've mentioned, is an OK. That means the resource has been fetched and is transmitted in the message body, which is fine. That's what it's done. The 302 is a found. So that means the resource requested has been temporarily moved to the URL given by the location header. A browser redirects to the respective page. And the final one, 404, that means it's not found. So the server can't find the requested resource. So in the browser, this means the URL is not recognized. So that wraps up the information that we've gathered so far. So moving on to the target path then. So the path to enter the credentials is inside a subfolder. So that's /login.php. Now when you enter localhost /DVWA in the URL field, you are redirected. So let's just put that in. And as you can see, we're redirected to localhost-dvwa-login.php. But at this stage, we aren't sure if this will be useful or not, but good to build a picture around redirects due to other indicators pointing to this rule or feature, which may help. So I'm going to switch over to CLI version of viewing web code. So I'm going to switch over to using curl, which is the CLI version of looking at web code. That's going to hop over into the terminal, and I'll demonstrate the behavior that we can see there as well. So we'll just cut out a lot of visual noise now. So you input curl localhost DVWA. So I'm essentially doing the same thing. We're going to do it in command line. When we enter this command, we get a response. However, when we enter localhost-dvwa with a dash, we'll see what happens. Here you can see there's no response. Might be a bit weird. So we can explore this a little bit more by adding a curl switch, which in this case is the I, and that switch outputs protocol response headers. So when entering curl localhost-dvwa, the server redirects us. So when entering curl-I localhost/dvwa, the server redirects us to a page which adds a trailing slash at the end, as shown in the location field. All right, so we didn't put a slash, added a trailing slash there. Now the HTTP header status code, as we saw, is 301 moved permanently. There's no field populated for the set cookie, which we'll see in a moment is on another. Now, when we enter curl-I localhost DVWA with this trailing slash at the end, we'll see what happens. Here we can see the server redirects us to login.php, as seen in the location field. The HTTP status code is 302 found, and there are cookie values as shown in the set cookie field. So that's the PHP session ID. Now what we'll do, we'll enter that path with login.php. And we just need to scroll up a bit, and we can see there's no location field, so there's no redirect here. The HTTP status code is a 200 OK, and there are cookie values. So that's the set cookie values. Now what I'm going to do is instruct curl to follow the links where possible so we reach the end of the communication. So this is done using the L switch in curl. So I'll show you what I mean. So we'll just take that back to DVWA with the trailing slash. We'll add our L switch on there, and we'll look at the data. So we just need to scroll up a bit. So when looking at the data given back to us, we see or can understand that the form method is post. And we can see that method clarified there. And this is where the username password fields are present. We also notice a hidden value. That's referred to as the user token. The next bit that we'll look at is that we notice the presence of the session cookie being set in this set cookie field. The name of the cookie is PHP session ID, indicating a cookie which is related to PHP. Now, PHP ses ID, what I'll call it from now onwards, is an auto-generated session cookie by the server. Now, as the name implies, it should be valid only for that current session. So this is a method a web application uses in order to recognize a particular user. Instead of having to store and send the user credentials each time, the session value is used instead to provide the authentication. The session cookie is being stored inside of the browser in this form of a cookie. Now we can resubmit the request, and we'll just press the up arrow here, and we'll press enter. And looking at the user token is here, and the PHP session ID, you'll notice that they refresh, so they're not static. If you want to check, just go back on the video. So there appears to be at least some level of security feature present in the infrastructure, so we need to bear that in mind when formulating our command. Now, if we switch back over to Web Developer Tools, and we'll go back to the single submission, so we'll just type in our arbitrary login pair, anything, press enter, update that order. Here's something that I noticed. So the PHP session ID seems to remain the same within a single submission. So I mean, all of this communication with that one submission is to be the same. We'll look at the 200 get and look at the headers, the cookies. There we go. So that starts 19EFT. And if we go to the post, that's 19EFT. And finally, the get request 19EFT. So what I can see from this data is that the PHP session ID only changes if we resubmit the form data. So if you resubmit this again, another user with a different username or password or combination or both for that matter, then this will change, but it doesn't change in that same communication. Hopefully that makes sense. Play around with it, and then you'll see what I mean if you're unsure. So what we'll do now is log in the form in CLI. So this is the high-level view of the login.php page. We'll head over back to terminal. So what we'll do now is log in the form in command line interface. So it's a high-level view of the login.php page. Relates to the first 200 get requests. So we can render the login prompt in text form, continuing in CLI form, and then we'll get a snapshot of the fields that are given in the response. So what I'm going to do is input curl localhost DVWA-login.php, and we need the L switch here to follow any redirects that might be present. We'll then pipe in a handy command which is HTML to X, and I'll just press enter, and this is what renders back, right? So this is the equivalent of looking at the initial get request and looking at the response in raw code. So if we do raw there, we get a simulation of basically, this is essentially the CLI equivalent of refreshing the web page. So this is the page server has fetched and giving back to fulfill the initial request. Now what we're going to do is do a deep dive into this kind of environment. So we're going to dig a bit deeper to see what code we submit and post to the server, i.e. the login credentials. And it would be useful really at this stage to see how this get request, the data page, is made up by looking at the underlying HTML code. Now, the code important to us is held within the HTML form tags, and that's something that we noticed earlier when we were looking at the user tokens, PHP session ID. But we can observe this data from the previous command, but just to condense it a little bit, what we'll do is put the data into a single page in CLI, and we use something called sed. We'll do curl, and then we've got a few switches here, and then S is silent mode, which doesn't show the progress bar or error messages. We've got the I switch, which is include, and that means outputs the protocol response headers, within which V, which is verbose, and that just adds a little bit of data so we can see what's actually going on. And then the parameter localhost DVWA-login.php. We close the parameter now, and then we're going to pipe in sed. That's sed, and then we've got the end switch as well. So sed is basically a stream editor, and basically what you can do is select text, substitute it, add lines and delete lines, that kind of thing. The end switch that I've used is a quiet option, and that's used to suppress unmatched text. We then put single quotes, /, and then we'll type in form / again, comma, / the arrow in. There's a /, / and then form / again with a and single quote. So once I take out the full stop at the beginning, that command looks okay to me, so I'll press enter. Now this code provides useful fields of the form. So it helps formatting and the syntax that we're going to feed into Hydra. To make it easier to drill down into these areas, what we need specifically now that we have this form data is we can extract the name and the value parameters by using grep. So that's just going to display us what we need in bold red format. So I'm just going to get the command back, which we were in before, type into that grep. So here you can see that's grep with the object switch and then the name value fields and then the formatting we need to kind of get the data that we need. Now with the grep switches, the O means only matching. It will only show the non-empty parts of the lines that match that text. And then we've got, just to press enter now that I've checked it, it all looks fine. Just before I do, need an E switch in there. So E is the extended version of regular expression. All right. That looks fine to me, so I'll press enter. And as we can see now, the red parts in bold tell us what we need. So the name, username, name is password, the value is login, and then we've got the user token value extracted there as well. So hopefully you're following me so far and you can see why this information is useful. Now, if we have a look at this login form again, we'll view the same data in GUI version. So we'll go back over to the web browser. Now, another option to using curl in CLI is to use the web browser, inbuilt web developer tools, or you can use it to kind of cross-reference information in GUI form as well and just clarify what you have made assumptions on. So whether you use CLI or GUI version, the data is the same. I tend to notice key data more easily when I compare between them. So if we go to the 302 post field, and we'll go to the request data. An interesting piece of data that we've found the presence of is a user token, which is here. And that's an alphanumeric value, probably a hashed code based on the format that it looks like. And that's submitted along with the arbitrary login pair that we tried earlier. So what we can do at this stage, if we didn't know what it was already, and what we would do in a normal scenario is establish what type of hash this could be by using either tunnels up or we could use hashes.com. So tunnels up just gives you a lot more additional information, which is really useful. Hashes.com, and of what you see, what you get, it does what it says on the tin. It just gives you an indication. So what we'll do is just use hashes.com for simplicity, and we need to copy this token. So we're essentially just wondering at this stage, right, what type of code is it? And that might give us clues as to what else we need. So we'll just paste that in here. And all we need to do is submit and search. Doesn't like that. So we'll see what I've done. Try another refresh. It doesn't seem to like that. Let me just try tunnels up. Go to the hash analyzer. There we go. All right, I'm not sure why hashes.com didn't work. It's normally quite reliable. But anyway, so hash analyzer, here we can see that it's indicated strongly, no additional info. That's either an MD5 or MD4. I was assuming along the lines of MD5, so that's kind of confirmed it for me. So we've got an indication of what the algorithm now is. Now I also noticed that the user token is generated with the 200 GET request. Let's just head back over. We're in the GET request. And also the 302 post. So here we can see the token, the GET, and I just need to input that login again. And then you can see the token value in there as well, but they will be different. So if we look at this one, so in the 200 GET request, the value is 020. We look at the 302 post, the value is A316. So that's indicating a fresh token is generated upon each submission, but the user token is different between these requests, unlike the PHP session ID. Now, if we do some research on user tokens, because we've got to imagine at this stage we don't really know what it is, especially some people out there won't know what they are. When we research user tokens, what we find is information which points us to the following. So user tokens are pre-generated. User tokens can't be used to authenticate to the user interface. So that means in, like, say, the URL fields, for example, and the user tokens are a form of authentication. So some new information, some things to confirm what we thought we already knew. So when I tried to re-enter or extract a user token from the developer tools and submit it within a new request to the server, I was presented with a message that was stating the CSRF token is incorrect. Now I'm bringing this information forward here because what I'll do now that I know what it was referring to is I will interchangeably refer to user tokens, which is what it's described as by the developer tools or the server, as CSRF tokens, or more accurately, anti-CSRF tokens, which is basically the true purpose of this code implementation. I'll cover this more in a moment. So that's a lot of information so far. So the information conclusion, or the learn so far. Based on the information gathered, I'm equipped with the following conclusion. So we have a PHP session ID and an anti-CSRF token, which are pre-generated and submitted along with the login pair as part of the login authentication process by the server. Now, so in a single submission, the PHP session ID remains the same in both the get and post request, that's between these, but the user token will change or refresh in between these get and post requests. That's really important to note and understand. The session ID is static for a period of time, which is the session. The duration of that session is managed by PHP as the settings of that code and the web application. However, the CSRF token is being refreshed or regenerated upon a page request. Now, this is an expected behavior of a feature which is designed to mitigate a CSRF attack. Now, CSRF tokens should not be reusable at all and not known beforehand to ensure that they meet their security objective, and that's preventing a CSRF attack. If they could be reused, then they could be crafted ahead of time, which would be a security vulnerability and therefore not be fit for purpose, as we could extract and use them. To check this theory, I'm going to head over to terminal again and go over to our friend curl and enter arbitrary values, including a random user token, which we know isn't going to be correct. So what we can do here is we're going to type curl with a few switches, so that -s, -i, -b, and we input dvwa.cookie. We're going to refer to it, -d, which is data, and then we've got username equals, let's say 123, and password equals 123. Let's be really creative. And login equals login, the button that it needs to press, and user token equals 123 again. Because clearly we can't think of any other numbers. And then we've got the path is localhost DVWA login.php, and then what we'll do, we'll keep our switch to follow any redirect. Press enter. So as we can see here, here's the key message. So message says the SRF token is incorrect. What we're essentially seeing is if we were to look at it on the actual web page itself, instead of login failed, that message would be there instead. Now the curl switches, as I've gone through S and I before, the -b, what that does is send the data to the HTTP server as a cookie. So it's supposedly the data previously received from the server in a set cookie line we observed earlier when we were playing around with curl. -d, that's the HTTP post data, and the -l, which I mentioned before, follows redirects if the server reports that the requested page has moved, indicated with a location header and a 3 something something response code, all of which match because we've seen that data already, right? We can also work out when the server has checked or is happy with the user token value, as when we entered arbitrary login credentials into the local host, which we saw on the GUI version, the response was login failed. So we know what the response of an incorrect credential pair is as well. We're starting to build some information which is going to be useful to us. Now the server appears to be paying attention to the validity of the user token prior to checking the login credentials, because this is the only error message that it's given. So this means even if the login credentials were correct, in theory we still can't authenticate with a valid user token or without a valid user token. So it's really key in crafting the command. So something to bear in mind, the PHP session is handled by PHP, whereas the CSRF token is handled by the web application. It's assumed these codes are being tracked since it was able to detect me trying to reuse a CSRF token, but we appear to be able to reuse the PHP session ID, which I was experimenting with as well. So we can conclude that session ID, that's PHP ses ID, and anti-CSRF token, that's the user underscore token, will need to be crafted and fed into Hydra as part of the brute force command. Just something to bear in mind, I'm not going to do it, but if you want to or experiment with it, we could have also used curl to pipe the output of submitting a standard login request versus the output of an incorrect login attempt, which we essentially did. So this would also provide a way to baseline and start working out what is different or changes in between those requests. And what you can do is you can color code the difference to make it easier just to basically see what is actually changing between them. And then you can compare the files in a format using diff as well. Now, as I said, I'm not going to cover it, but if you want to look at my write-up in the article, I'll give you the commands in order to do that if that's something that you kind of want to look into further. Right, so let's move on. We've gathered enough information about the infrastructure and have a really good idea of how, where, and what information is used to formulate our Hydra command. First, I'm going to show you how the correct working command works and the output that it shows us, followed by a full breakdown of how and why the command was built out the way it is, because you may see different variations of this and wonder why there's variations of it. So what I'll do is kind of explain each part of mine so that you can add or amend it as you see fit. I'm going to clear the screen now and we'll have our Hydra command up and loaded. And just to be clear, this is the line here that I've entered as the command, which is successful. So I'm going to break this down in each section so you can also have a rationale. And the reason why I'm doing that is because the different variations that you'll find will have different outputs to them. And I'm just going to re-go over some things that I mentioned earlier in the beginning of my video. And that's just to notice how the form path is correct. So we're cracking the actual page that we want to, not the task. Let's not confused here. We've got the right login username and password. It's only found one valid password, which is the goal, and it hasn't found false positives here. So there shouldn't be any more than one result here. If you have, then you're getting false positives and you haven't actually cracked it. So with all that said, let's start breaking it all down. You may hear me recovering certain points, and that's just because what I want to do is to have a better flow, especially for people following from this point on, and it will just kind of just make it a bit clearer. So apologies, I might be repeating some things, but also I'll explain it in different ways, so that might be useful to others. And if nothing else, it's always good to double check and cross-reference information to avoid unnecessary errors. So the first section, which is right here, that's Hydra in green, and then localhost. This basically calls the program Hydra, followed by the host name or IP, which in this instance could also be 127.0.0.1. Next, we move on to HTTP post form post. And if we launch Firefox again, go into the source code, we can see when we're typing anything, i.e. a username, password, we try to log in, we can see when we do that, this is where we've input the details, that won't appear on these two because this is post, this is the data that we're submitting to the server, is a post method. So this reminds us also of the redirection in place, which is the 302 message we covered earlier. So this data will usually help crafting a failure flag for Hydra because we have some clue as to what the output of an incorrect login pair or credential looks like. So this explains why we will use post form method. So the next section is this part here, DVWA login.php. This value is simply taken from the URL path from the URL field. So if you are on another exercise, you're just basically extracting it from here. This also confirms and checks that we are focusing on the main login page and is the correct path that we're trying to brute force. We go to the next section. That's username equals user and password equals pass, so up to that section. So using the 302 post and curl we used earlier, we see values that we will need to pass into Hydra, which are username and password. We can also see the full HTML form data in the first 200 get response, which is in raw code. And then we can see if we scroll down and use this information, here we can see the username, the labels, the input types, etc. And that's the key information that we're referring to here. So this is interpreted as username equals user, and that converts it basically into Hydra-friendly syntax. We essentially focus on the name and value fields. The same concept applies to the password fields as well. All right, next bit is this section here, which is the user token and CSRF. Now, this bit's interesting because initially I created a variable to generate user token and the PHP session ID values. I assume the token and ID were not literally tied or linked together as a pair, like say the connection between a public and private key in cryptography. Now, after spending some time experimenting with a variable which generated new fresh user tokens and PHP session IDs, for some reason it wasn't actually able to brute force. Now, my theory is that it's probably because the variable generated a fresh set of values, but when running the Hydra brute force command, it was only fresh for the first brute force attempt. So theoretically, on that basis, it would be reusing the PHP session ID, which testing demonstrated was accepted by the server, but not the user token. That removes the ability of preventing the CSRF attack. Now, after I took a break and came back to my system and I turned it on from a cold boot, I was going through the process of debugging Hydra's command to see what was actually happening, and I ran my command and it cracked the password. So I realized that I didn't actually set a variable for the user token, that's this CSRF variable here, and the session ID, and these were actually empty. So I ran the command in debugging mode so I could actually try and understand why it was working, as essentially I inserted a placeholder for these values without actually configuring the input. Now, in debugging mode, I could see the PHP session IDs were actually being generated, hence why the brute force was actually successful and it worked. Now, I learned that when using a placeholder without a value, in this particular scenario and environment, the server appeared to actually assign a value instead. So this meant that the server was generating the values itself in whichever way or method it was designed. Hence, it would always be valid, which was, something that I just stumbled across by accident. Now, here I can show you, following on from that successful command above, that there are no variables attached to these. So how you do that is you echo them out, you echo CSRF, and you can see there's no value to that. And just to show you the session ID, enter that, there is no values to them. If there was, the value would basically just output here. So that clarifies there's no actual variables set to these. They're empty placeholders. So that clarifies that there's no variable set, because if there was, what you'd see when it echoes here, you'd see the actual values assigned to them. And in this case, they're blank because they're essentially empty placeholders. Now I'm going to show you the command in debug mode in Hydra, which is essentially the D switch, and also the V switch, which lets us correlate the password attempt into human readable form, and also the F switch, which will stop the command execution once a valid credential is found. And that just basically gives us a way of cutting off or separating the data. When you look at it, it can seem pretty overwhelming. I'll put this output into a file, which I'll create a link for if you want to inspect and see it for yourself. I'll call it Hydra Success Debug.txt. So just have a look and scroll through that so you kind of have a baseline of something to compare. Or if you want to inspect my code, then feel free and do that. So bring up the command again, and then we'll just add the D switch as I said earlier, and we'll run that again. In fact, what I needed to do is also add the V and F switch, which I forgot. So I'll run that again. And there we go. So that will basically show us the credentials. We've also got the human readable form data here. And without going into a whole load of detail here, all I just want to kind of prove the point of is, as you can see, session IDs are being generated. And if I can find a user token attached to one of the other attempts, user token values are shown here. Now the user token doesn't have a value to it, but the server is communicating with that empty placeholder. And as you can see in this one, for example, username is admin, password it's attempting is Jessica, and that's iterated that successfully, and it hasn't met the flag, so it's just continued on until it's got to the last one. and then stopped because it's found a match which meets the flag condition. Just go back to our Hydra command, and now we are at the stage of login equals login, which is here. Now this input is taken from the 200 get response data. Let me just switch over. And you can see the fields here. What we are doing is mimicking the equivalent of physically clicking login or enter on the keyboard after each login attempt. So that allows Hydra to iterate and cycle through a list that you give it. So the code shows us kind of that long string along here. And technically, we are after the name and value fields. That's the name there and value field, which are login and submit. If you look at the type, which also works as well. So if you do login equals submit or login equals login, both of them seem to work when I was testing it. Right, now the flag. So the flag that I've used is success, so that's S, equals index.php. Now this was the pivotal part for me and was kind of what led me to crack the actual site. Normally I don't use the success flag. So S is something that is a success, so i.e. something that you instruct Hydra to look for, whereas the F, failure flag, is something that you're instructing Hydra to ignore everything which has that value. So similar to the concept of a file, so when you have the allow or block list, kind of similar concept. Now I say this because you're more likely to know the output of a failure message than a successful message, right? That said, there are some situations where I think you could obtain a success message. So if you were looking at a web server, for example, what you could do is create a new user on that website and log in. You've just created it, and then you could see what the success message is. So it might be welcome Mr. or Mrs. such and such to your user area. So that kind of data that you're looking for. So what it spews out when you're actually able to log in. Now, I initially played around with the failure flags, but these attempts just took ridiculously long time. And in theory, a failure flag such as f equals login.php should actually work smoothly. But when I was experimenting, I used a successful... Now, in theory, a failure flag such as f equals login.php should work smoothly. But when I was experimenting, I was successful using a success flag where the results basically return far quicker than the results of my failure flag. In the end, I didn't want to wait around long enough for the failure flag command to finish executing. So to clarify, I'm not saying that the failure flag of f equals login PHP won't work. I'm just saying that in my trial with this failure flag, it just ended up being inconclusive. So what was my logic behind using a success flag, given that I was intending to use a failure flag? Now, when we enter incorrect credentials, we are redirected back to the login page to try again. That's normal and somewhat expected behavior, along with some kind of error message, both of which occurred in our case. So we're redirected back to the login.php page, and the error message is login failed. So refer back to the earlier portion of the video if you kind of want to recap. However, I anticipated the same would not be logical if you entered correct credentials. It's still unknown at this stage. So in this case, should be redirected to a sort of user welcome area, which to me would be a standard and sensible login flow. So if you enter incorrect login credentials, you're sent back to the login.php path to try again, right? So that's fine. So my logic is that you would not be sent back to that same path if you entered the correct login credential. So now I have an idea of what not to look for, the failure flag, but also something that Hydra should look. So now I've got a success flag, or I'm trying to have. So perhaps due to the redirection in play causing a problem. Now, leaning on some experience from web development, I knew that inputting index.php at the end of the main URL or domain can redirect to the root folder or homepage. This is essentially what I wanted to do, so I could get the server to generate a valid user token and PHP session ID, and maybe anything else that I could have potentially missed at this stage. I tried it in a web browser. So I got Firefox, and show you what I did. I changed this path here and put index.php, and then you can see what it does there is redirects us to login.php. I'll also just throw this up on curl as well. So if we do curl-i- anything to HTTP, then put our URL with the index.php, And we now press enter. I've forgotten to put another switch, which is U for the username, and take that out. There we can see that even though we're going to index.php, the location tells us there's a redirect. Where has it gone to? Login.php. Brilliant. This is exactly the behavior I wanted for the reasons explained just a moment ago. And then when I tried this theory did indeed work, and it was my first guess. Now, that just relied on experience that I'd had before, but you, in a similar situation, if that didn't work, all I would have done is just try different well-known welcome path of what they could be. Now, here we can see in the location field is login.php. That's basically where the server has sent us to. What I found was Hydra was better able to detect a successful login path and completed the brute force attack very quickly without any additional switches to configure the timing or wait times. Now, it would have been fun to work this out, but in reality, guesswork is also a valid methodology. If it didn't work, then I'd also then dig deeper into finding out why the failure flags weren't working, which is essentially deep diving into redirects and using Hydra in debugging mode. But a short time later, my OCD kicked in and I wanted to find out anything. After doing some research and using curl, it appears that we can send as many post requests as we like, reusing the same PHP session ID and user token, subject to not following any redirects. So in curl, that's when we use that L switch. Now, when sending a GET request to follow the redirect, a new user token is generated. Whilst this may be a good security feature, it means we can't use the error output of entering incorrect login credentials of login failed as a failure flag, because this is only valid with a GET request. Hopefully that makes sense. Now, if we were using Burp Suite, then it would also probably rule out using the content length as an indicator, as it'll always be 0. So no, I also checked what would happen if we tried login.php as a success flag anyway, just to see what happens. And then I'll just bring this up here, go over to success flag, and we try login.php. And as you can see, this resulted in 16 valid password found. So clearly this is showing us false positives, as we know there's only one correct log. All right, so moving on. We now go on to this section here around the cookie data up to the PHP session ID. All right, and that will complete the parameter values. So the easiest way to extract the cookie related values, including PHP session ID, is to look at the 200 GET request. And we'll just go back to the header here. We'll go to the headers and we'll look at the header request there. And we'll just convert that into raw form. And then you can see that field here as highlighted. So we can easily copy and paste the cookie related data, and we always start that field or line using h equals cookie. Now for the PHP session ID and user token, which I covered off earlier, I mentioned that created variables which later were not required. So these ended up being empty placeholders. Initially, it seemed the PHP session ID and CSRF token were implemented somewhat securely, as we couldn't reuse the CSRF token again, and they were being generated fresh each time, and the server appeared to be keeping track of the codes. However, as my brute force attempt worked without even setting the variables, it turns out that it may not have actually been implemented securely or correctly after all. And if you wanted to reconfirm if the login submission is generating a fresh set of data for the user token and or the PHP session ID, then you can use curl again and just re-enter the path and submit them. All right. That brings us to the last section here, -L, admin, and the P for password. So these values instruct Hydra to use the username admin, so I've just fed it in this case. Therefore, it won't brute force the username field, but it will brute force the password field, which is in a capital P. The path that I've given it is to use an inbuilt word list, which is in the rockq.txt file, which is pre-installed in Kali Linux. So I've pre-fed the username admin in case we need to troubleshoot, as it just saves time during the brute force process, as it will just take longer to find out whether you were correct or not. So if we wanted to now, we can actually pass a list into the username field. So what we'd do here is we'd change that to a capital L, just there. And then we would give this a path like we did with the password as well. And then lastly, what we did is we'll just go back and execute Hydra. And then essentially this is what we ended up with. Now that I've executed it, that's the output. And as you can see, it's found the right login pair. So the Hydra success. So Hydra was able to find a match for our condition. So that's the flag. So what I'll explain now is what that command actually did. The Hydra was able to use the success flag, that's s equals index.php, to identify the login credential pair that, when attempted, results in a response which has index.php. Remember that we are assuming that a valid login is linked to being redirected to a page other than login.php. So we are assuming it could be index.php at this stage because we haven't proven it. Basically, it's just another page that's different to login.php, and we're hoping that it'd work. Now, Hydra doesn't know at this stage that the user credentials are even correct. What it's telling us is that it just knows that it's found a response which matches the success flag condition upon entering these credentials. That's highlighted in that sort of turquoise color in bold, just in this section. What we can now do is have that little bit of excitement where we need to actually try these credentials to verify they are in fact correct, and our theory up until now can be proven to achieve the goal of a successful login. Now, you've seen me do it already, but kind of in the flow of things, what you do is type in admin here and password in that section. We'll press enter, and there we go. We'll move the developer tools now, and we're successfully logged in. So here's the result of inputting the login credentials filtered out by Hydra. Right, so the summary, outcome of what we can break down. So we can now confirm, going back Hydra command, we have successfully logged into the main login page of DVWA. Hydra has found the correct login credentials, so that's username is admin, password is password. The success flag was effective in finding the desired credentials. We are redirected to the DVWA/index.php, and this was the welcome login area. As we can see, that's where it takes us to. Before we instructed Hydra, we just guessed that it could be using a commonly known login welcome area, and in fact it was. And finally, that the web server uses the post method to submit login credentials. So all of our theory up until now was unproven, but we have been able to prove it. So that concludes extracting the correct login credentials on the main login page, login.php, using Hydra. I really hope you found my resource useful, and if you want to bring anything to my attention, then feel free to connect to me. I have left some useful links in the description below, and my write-ups on my website and on Medium as well, if you want to comment or add anything for me to look at there as well. Thanks for watching.